Hello students, welcome to lecture 1 of S-block elements. Let us discuss the introduction of S-block elements. The elements in which last electron enter into the s orbital are called S-block elements. S orbital. So the elements in which the last electron enter into the s orbital are called S-block elements. And the s orbital can accommodate only for 2 electrons. Accommodate for only 2 electrons. We know that. So this is the s orbital. So this s orbital accommodate only for 2 electrons. And the first group and second group elements are S-block elements. First group means first A and second A group elements are S-block elements. S-block elements. Now let us discuss the group 1 or first A group elements. These are also called alkali metals. Alkali. The group 1 or first A group elements are also called alkali metals. And they give hydroxides when they react with the water. For example, if you take sodium, the sodium react with water, then it will give sodium hydroxide, NaOH. And next, electronic configuration. All the alkali metals have one valence electron. So their common outermost electronic configuration is NS1. In first group elements, the first element outer electronic configuration is 1s1, and second element outer electronic configuration is 2s1, and so on. So the common outermost electronic configuration for first group elements is NS1. And all alkali metals can easily lose their one valence electron. Then they can form monovalent ion, M+, monovalent ion. So they are called most electropositive metals. Most electropositive metals. For example, the sodium can form Na+ and potassium can form K+. So here, let me take that first group elements. So here, the 1s1 is the outermost electronic configuration of hydrogen, and 2s1 is the outermost electronic configuration of the lithium. We know that the hydrogen position, already we discussed that the hydrogen having a similarities with the first A group and 7th A group. If the hydrogen is placed in the first A group elements, then the hydrogen outermost electronic configuration is 1s1, and next element lithium. The lithium outermost electronic configuration is 2s1. So here element, first element lithium, and the symbol of lithium Li, and electronic configuration 1s2 and 2s1. Or we can also write that 1s1 means it is equal to noble gas of helium. So helium and 2s1. And next element sodium. The symbol of sodium is Na. The sodium scientific name is natrium. So that's why we are taking Na, natrium. Natrium. And its electronic configuration. So we know that the sodium atomic number 11. So number of electrons in sodium 11. So for that 11 electrons, electronic configuration 1s2, 2s2, 2p6, 3s1. Or also we can write that up to 10 neon electronic configuration and 3s1. And next element, potassium. The symbol of potassium is K. Its scientific name is kalium. So that's why we are taking K. And its atomic number 19. For that 19 electrons, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Or also we can write that up to here 18 electrons. So 18 means argon and 4s1. And next one, rubidium. The rubidium symbol is Rb and its atomic number 37. And for that 37 electrons, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4p6, 5s1. Or we can write that krypton 5s1. And next element, cesium. And its symbol is Cs and atomic number 55, number of electrons 55. So for that 55 electrons, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6 and 6s1. Or we can write that xenon 6s1. And next element, francium. And this francium is a radioactive element. Francium is a radioactive element and its symbol Fr, atomic number 87. For that 87 electrons, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10 and 4f14, 5s2, 5p6 and 5d10, 6s2, 6p6, 7s1. Or we can write that radon 7s1. So these are the first group elements: lithium, sodium, potassium, rubidium, cesium, francium. Here the lithium atomic number 3. So this is the electronic configurations of first group elements. So here the common electronic configuration. The outermost common electronic configuration is NS1. The outermost common electronic configuration is NS1. See here, for that lithium 2s1 and sodium 3s1, potassium 4s1 and rubidium 5s1 and cesium 6s1 and francium 7s1. So we can take that NS1. Next one, atomic and ionic radii. The alkali metal atoms have large size. large size. With the increase in atomic number, the atomic size will increases. If atomic number increases, then the atomic size also will be increases. When we go from top to bottom in a group, means if you go from lithium to cesium, so the top element is lithium and the bottom element is cesium in first group. So if you go from lithium to cesium like this, if you go from lithium to cesium, means top to bottom, the atomic size increases. Atomic size increases. Hence the radii increases. Hence radii increases. With the increasing of atomic size, radii also will be increases. The monovalent ions are smaller than the parent atoms. So here the monovalent means, for example, M plus. For example, if you take Na plus, that Na plus ion size is smaller than the parent atom. Parent means here Na. So Na plus atomic size is smaller than the Na. So the monovalent ions are smaller than the parent atoms. Here the sodium size like this, and the sodium plus size will be like this. The monovalent ions are smaller than the parent atoms. And next one, ionization enthalpy. The energy required to remove the electron from outermost orbital is called ionization enthalpy. So here the ionization enthalpies of alkali metals are low when we compare with the other metals. So here the ionization enthalpy of alkali metals are low. Alkali metals means group 1 metals will be low when we compare with other group elements. And ionization enthalpy decreases from lithium to cesium. So the top element is lithium and the bottom element is cesium in the first group. So if you go from top to bottom, means lithium to cesium, the ionization enthalpy decreases because the size increases. Because size increases and outer electron screened from nuclear charge. So here the size increases, because of that the ionization enthalpy decreases. If the size increases, we can easily remove the electron from outermost orbital. For example, if I take the lithium size, so this is the lithium size, and the cesium size, so this is the cesium size. For example, this one is the lithium and here it is a cesium. So here the center part is called nucleus and this one is the outer orbital, outermost orbital. So here there is a more attraction between the electron which is present in outermost orbital and nuclei. In the nuclei we have positive charges of protons. So there is a attraction between the positive charge of proton and negative charge of the electron. So here there is more attraction between the positive and negative. For example, if you take the cesium, so the distance between the nucleus and outermost electron is more. So we can easily remove that electron because the attraction is less between the negative charge of the electron and positive charge of the nucleus. So we can easily remove that electron from the outermost orbital. So the ionization enthalpy decreases from lithium to cesium. Next one, hydration enthalpy. The energy released when 1 mole of ion react with water is called hydration enthalpy. When 1 mole of ion react with water, then the energy released. So this energy is called hydration enthalpy. The energy released when 1 mole of ion react with water is called hydration enthalpy. The hydration enthalpies of alkali metals decreases. Hydration enthalpies of alkali metals decreases with increase in size. So the hydration enthalpies of alkali metals decreases with increase in ionic size. For example, I am taking lithium plus and sodium plus, potassium plus, rubidium plus and cesium plus. So these are the alkali metal ions. Hydration enthalpy decreases. So the lithium plus, it has more hydration enthalpy. The lithium plus, it has more hydration enthalpy than sodium plus and potassium plus, rubidium plus and cesium plus. And here the sodium plus, it has more hydration enthalpy than potassium plus but less than the lithium plus. And here it having more than rubidium and cesium and less than sodium and lithium. And here also same, that rubidium, it has more than cesium and less than potassium, sodium and lithium. So the hydration enthalpies of alkali metals decreases with increase in ionic size. So here the lithium plus has maximum degree of hydration because the lithium salts are mostly hydrated. Example, lithium chloride and 2H2O. It is a hydrated lithium chloride. So the lithium plus has a maximum degree of hydration because the lithium salts are mostly hydrated. Next, physical properties. All the alkali metals are silvery white. So the color is silvery white. And they are soft. The alkali metals are soft and they are light, means they are having a less weight. And these elements have low density. Low density because large size. Because of large size, the density of the first group elements is very low, and the density increases from lithium to cesium. Density increases from lithium to cesium, means the cesium having more density than the lithium. And these elements have low melting point and low boiling point. The first group elements having low melting point and low boiling point. And the alkali metals and their salts. The alkali metals and their salts shows color when they are exposed to the flame. So Here I am taking the metals lithium, sodium, potassium, rubidium and cesium. There shows the colors when they are exposed to the flame. So if the lithium exposed to flame, it shows crimson red color. Crimson red. And when the sodium exposed to flame, it shows yellow color. And potassium shows violet color. And rubidium shows red violet. And cesium shows blue color. So these are the physical properties.